where you kept coming up with a new username and says taken and saying like, damn it, bothers me. It's there. Okay, whatever. Fine. I'll be out. All right, guys. So, where do you want to start?
Here. The beginning.
In the beginning. In the beginning, there were numerals, and God created the integers. And He said, "Oh shit, what have I done?" Who said that? Was it? Were you just joking?
Yeah, in the beginning.
Huh? The beginning. Not the beginning. Somebody said, "Okay."
Oh.
You guys, okay. It was good seeing you.
I was serious.
Does anybody have any questions from the practice test, from homework? It's cool with me if everybody knows everything. That would be the day. That would be awesome. That will be the day.
Oh, heck no, I have a question.
Hold on. I got one.
6.4, the sample median probability, the standard deviation probability.
Oh, yeah. All right. So this is... you want to look at example 1. And no matter which version of the book you're in, they already set up a table for you for most of the problems and numbers you're using. So in the new edition, you're using the numbers 4, 5, and 9, right? And if you'll notice, example 1 uses 4, 5, and 9. And so how do I figure out the population variance for this?
Get the mean.
How's the variance related to the standard deviation?
You square it.
Yeah. So sigma squared is the variance. How do I find standard deviation? What do we do it? How do we do it now that we're out of chapter 3? Chapter 3 is where you had to make x minus x bar squared, sum of them up. You had to do the tables. How do we do it now that we're out of chapter 3? Use technology, one var stats. All right? So you put, to find the population variance, you put your giant population of 459. That right there might throw people off. You're looking for, like, what's your population? I don't see it. It's tiny. Your population is always the one you're sampling from, and we're just sampling from these 3 numbers. That's my population. Cool? So you put that into list 1. One var stats, get the standard deviation, get sigma. And of course, how do you find the variance? Square that. Now they've already made the table of all possible samples, sort of like that sheet we went over last time. That had in yellow all the possible samples. So if you look at example 1, 4, 4, 4, 5, 4, 9, blah, 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 blah. Here they have means, so instead of mean, I'm going to have sample variance. You guys semi with me? Example 1 sets everything up for you. Instead of the mean here, I'm going to put the variance for each one of these. Now, for 4, 4, 5, 5, 9, 9, you should have to do no work. How much does 4, 4 vary? Beautiful. So for each of those, 5, 5, 0, 9, 9, 0. But for 4, 5, plug that into list 1. Get S now. Why would I get S and not sigma? Because it's a sample. It's crazy. So I'm going to get S and square it for each one of my samples. Unless it's an easy one like 5, 5, and then I know it's 0. Why would you waste time? Do exactly what they did in example 1. Once you get all of those, you just take the average and compare it to the actual variance.
What does variance tell us again?
Variance is a weird little dude because he's the square, like if you're talking about people, it would be people squared, which would be really weird. Or little dog squared, right? I don't know what that would be. So it's like a middleman for the most part. It does have some meaning, and when you do this, the mean you get here, the average of all the sample variances should equal the population variance. But if you did this for standard deviation, it wouldn't work. So later in the book, we use variance instead of standard deviation because of that fact. The variance targets All the sample variances target the population variance. And if you've read or done any work in chapter 6.4, that word target should have shown up by now. Right? It targets that. The standard deviation doesn't. It doesn't quite work that way. It doesn't work. So it does have a usefulness, at least mathematically. Right? And there's more to it than that. We just don't get into it yet. But for right now, it's like a middleman for us for the most part. Do you guys want to do this and then... Because I think the other homework is like the medians and the everything else. You want to do one of these?
Yes.
All right, so let's see. Let's get real here then. Let's see.
And what if we don't use the calculator to do the top part?
Yeah, the S2.
The bars? Would that like...
I mean, I can't complain if somebody decides not to use a calculator. That's just, but in this case, that's just silly. Because to not use a calculator means you'd have to do x minus x bar. I don't know how else you would do it. Is that what you wanted to do?
Mm-hmm.
Sure. It's just such a backwards thing. I'm not used to that. Teacher, I don't want to use a calculator. I've never
They freak me out.
heard that, ever. But at the same time, you also need to know how to use a calculator. So if that's the problem, we need to work on that. So, they give me the samples. So 4, 4 is 0. 4, 5, 4, 9. 5, 4, 5, 5. 5, 9, 9, 4, 9, 5. That's all the possible samples of size 2. And they give that to you. It's already created for you. It's nice. So that's 0, and that's 0. Now you guys help me out. What's 4, 5? Put that into list 1. Yes, ma'am.
What number is this?
Oh. You don't know what number it is? What was the... Which number is this? 7. No. Yes. Number 7. 6-4.
Yeah.
What is it? Section 6-4? Yes, section 6-4. I thought you were telling me that's the answer here. I was like, no. Somebody got that? Put into list 1, 4, and 5. Put into list 1, 4, and 5. And then go to stat, calc, 1 bar stats. That's the quick way to find the average standard deviation. What do you guys get?
How would you enter 4, 4 though? You just put 4, 4.
No. All right, so in list 1, it'll be 4, 5.
5 and 9.
Yeah, so this is spot 1 and spot 2. That's how we enter data. This is just a list of data. When I make a list, I put commas. But when I put it into list 1, 4 is in the first spot, 5 is in the second spot. So has anybody got that for me? Should have brought calculators. Has anybody got that for me? Let's start here. No, you tell me. All right, so it looks like we need to start here.
I don't know anything about this calculator. I know I go to bars. No, I go to stats.
So we're using S,
Calc,
not
bars.
sigma?
What do you do once you get to
Yeah,
bars?
so what's sigma for? What's sigma for?
For sample. Or for population.
Population. And here, these are samples. So I definitely want to get S. Calculator is going to give me both. Because calculator is not the human here. It just doesn't know which one's which. Thank God we still have something over on the calculator. So edit. So go to stat. Get this. Edit. And then here I can put in there 4, 5. Right? And then go stat, calc, 1 bar stats. And it tells me the mean. Tells me all this stuff. The sum of them, thank you, 4 and 5 is 9. That's neat. Which number do I want to put up here? It's not even there yet. Which number do I want to use?
0.707?
Yeah, 707.1. Let's go out to 4 places. Because then what do I want to do with that number before I put it here?
Square it.
Square it, because I need to have variances here, right?
Yes.
Okay. This is not horrible. We can go back to how we did in chapter 3 if you want. So, take that 0.7071 and square it. Pop.
5.
Yeah, let's just say 0.5. 0.5. So that means what else is 0.5? 5.4. Where's my 0 at? Let me look at you straight on there. There you go. So then when you do 4.9, the answer will also be true for 9.4. Right? So you go back to stat, edit, make it 4.9. Stat, calc, one var stats. So what number do I want to use now? Yeah, 3.536 roughly. .503. So that goes here and here. How are we doing so far? So now that we're out of chapter 3, I told you before chapter 3's test, I said you're only going to have to do these tables to find the standard deviation this way for now. Anytime after that you need standard deviation, you can use one var stats. So now we're in that situation. We need standard deviation. We need a bunch of them. I don't want to make a table for each one of these situations. Good Lord, no. So now I can do 5.9. That'll be the same thing as 9.5, and then we'll be done with this list. So now if we go back, change 4 to 5. Stat, calc, one var stats. So I want to use the number 2.828 squared. 8. What's that? Oh, yeah, about 8. So, yeah, that's close enough to 8. So that's 8, 8. Now, I don't think the problem asks you to make a histogram, does it? Blah, 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 blah. No. So you don't need to make this probability thing here either. I mean, that would be if I want to make a histogram, I can make a relative frequency. That's what the probability is. I just want to find the average of these. And what's a quick way to find the average of these?
Add them all up and...
Yeah, it's not very long unless you can just add them up, divide by however many there are. All right, 3, 6, 9. Yay. So if I add all those up, let's see. Now I'm curious. 0.5 plus... Let's see, I got a couple 0.5s. 0.5 times 2 plus 12.5 with 3 times 2 plus 8 times 2. Enter. So that's the sum, and then divided by 9. 4.667. So then the average of the S squares is 4.667. Now, how do I find the population variance? How do I find the variance for any list of numbers? How do I find it? We just did it many, many times. So how do I find the variance for any list of numbers? Put the numbers into list 1, and then do one var stats. Come on now. Anytime I got a list of numbers, I want to get the standard deviation or the variance, I just do that. Right? So I got a list of numbers 4, 5, 9. So if I put 4, 5, 9 in, 4, 5, 9, stat, calc, one var stats. Which number do I want to use? 2 point who what?
2.64.
No.
1.6.
2.160. Why? Because 459 is the population. That's what I was choosing samples from. Right? 459 is what's in the calculator. Now, I know that's a population. I'm the human here. I'd get the right number off the screen. Right? We still have something over the calculators. It doesn't know. It says, here's everything. Stupid little calculator. And we go, no, come on, dude. It's a freaking sigma. Let me say it again. Some of you guys have pained expressions on your faces. Why were each one of these the squares of s's? Why did we pick the s for each one of these? Because each one of these are samples, and s goes with sample, right? Our letters go with samples. Greek letters go with populations for the most part. Not always. So when I put 459 in there, that is a population. I know it's not big, but there's nowhere in the definition of population that says it must be big. Even if it did, the word big is ambiguous. That's really, really big. Compared to one person, it's 3 times as big. Holy shit. Anyway, so that's my population just because it's what I'm choosing samples from. That's my population by definition. So what do I want to get when I put it in there? I want to get the sigma. I want to get the one that stands for population standard deviation. Of course, what do I want to do with that number? Square it to get the variance. So what is 2.16? That's good enough. Squared. That looks roughly familiar. Considering we rounded a bit. It's the same damn thing, basically, right? So the average... Now this is... I don't know if you guys are with this at all. If I take samples, so like we said the other day with means, it's very simple. If I take 2 people at a time and take the average of all those averages, it's the same stupid number as if I took 1 person at a time and took the average of all their individual scores, right? That only makes sense. It's still the same people. I'm taking 2 at a time. But not every parameter works that way. Oh shit, what's the word parameter mean?
Population.
Yeah, it's something that describes the population. I like it. So the population mean equals the average of all the sample means. That's how we kind of like stepped into this whole idea. We started with means. The population variance equals, even though it didn't for us exactly, it's because we rounded. The population variance equals the average of the sample variances. If you do the same thing we just did and don't square these numbers, leave them standard deviations, which would have really been a good idea for you because I think one of your problems is to do that. If you would have kept track of the standard deviations, you would have had less work to do now. But if you average those, it will not equal 2.16. Blah, blah, blah. It won't. It won't be close. It'll be close, but it won't be like this close. You guys kind of with me? So, sample standard deviations do not target the real population standard deviation. They don't. And it's because of the square rooting thing that we do. But sample variances do. They tend to go towards the actual true population variance. Okay, maybe. And I'm going to bring that back up when we start analyzing variances directly later. You'll wonder, why are we starting with variances? Because of this fact. It's the variances that target the population, the truth, the population value. The standard deviations, if you do this thing, no, they don't. That's part of the reason why I assigned this. I assigned these problems because they have an example that already kind of sets it up for you. Because it is weird, I will give you that. This is nothing related to anything you normally do. You don't wake up Tuesday morning and go, gotta make my table of standard deviations. No, so it's weird. It's very strange. But I need you to go through it to see if you can get something out of it, to see that's really going on. Okay, so you do. Another problem is, I think another problem says standard deviations here, right? And another one says medians here or something. Let me see. What problems did I assign? 7, 8? Ooh, I'm evil. I like it. So number 8 is exactly this, except you put standard deviations here. You don't square them. You can just square root these. That'll be close enough. That's really bad. You round it again, and then you round to get back to it. But still, it might be close enough. Number 9 says sampling distribution of the sample median. So you're going to put medians here. And the medians just go to hell. I mean, if you really think about it, why would the average of sample medians be anything to do with the population median? If you really sit down and think about it, that just doesn't make sense why it would happen. So when you do this work, when you get the median, what would the median for this be?
4.
It's crazy. What's the median for that?
4.5.
So you don't need a calculator for this, do you? For the median. It's just the number in the middle. Average those. What's the median for the population? Come on now. What's the median? 5 is in the middle. It's only 3 numbers, so the one in the middle, oh, no, don't you? Okay. So that's the 5 is the population median. Are you with me? Population median is also this, by the way. It doesn't have its own little symbol, right? We'll pretend it's like Roman numerals. Yeah, no, screw it. But put medians here, take their average, it will not come out to be 5. Let's do it real quick. This is the last one I'm going to do. I got to leave something for you guys to do. All right, so the median here was 4, like you told me. The median here was 4.5. What's the median? 4 and 9?
7.5?
Close?
6.5?
6.5. Median 5 and 4?
4.5.
Yeah. 5 and 5?
5.
5 and 9?
5.5?
Nope.
7.5.
7. So 9 and 4 was 4 and 9 is 6.5. 9 and 5 is the same as 5 and 9, 7. What is that trying to be? 9 and 5? What is that trying to be, Jeff? You're crazy. And that's 9 and 9? It's 9. All right. I didn't do a very good job here because it's in the book. So screw that. That's why I didn't want to write well. So if you take the average of these, somebody help me out. Take the average of these.
4, 10, 11, 15, 19.
Do you understand what's happening here? We're trying to see which statistical analysis numbers, the mean, the standard deviation, the variance, the median, which ones of these, when I do samples at a time and try to put them back together, take the average of all of them, which ones actually become what the whole population is? The mean does. The mean, it totally makes sense. We don't have to do any work. Of course the mean comes out the same. Take 2 people at a time instead of 1 person at a time. Ooh, Jeff, it's going to come out to the same stupid average, right? The same mean. But the variance, I don't know. Shit, we did it, and it came out. Standard deviation, I'm going to let you guys do. Median. What is the average median?
6.
And what's the actual median? 5, yeah. If you think about it, I could have put a 6 there, but that would have changed these. The middle of each sample average has nothing necessarily to do with the actual middle of the whole population. They have nothing to do with each other. So actually that work shows you the median, and that actually is kind of like a backward step. Nobody asked me this, and I think I said something really quick, but we had the whole chapter, the whole section about all these different middles. The mean, the median, the mode, the mid-range, right? Mm-hmm. And then I just said, okay, the mean wins. Here we go. And here's a good example of why it wins. It actually targets its parameter. All the sample its target the parameter of it, right? Medians, no, they don't. They're all their own little thing. You average them. There's nowhere near the real one. Screw it. That's another reason why mathematically we use the mean to do more things, because actually they target the real mean. What that means is the more little samples I take, the closer the average of all of them will get to the real mean. The median, I have no guarantee. Because here, I did every damn sample there was, and it wasn't right. Shit. So, take more and more. We've just proven you're guaranteed to end up wrong. But the more samples I take, the larger samples I take, the closer I must get to the mean. That's why it's so much more useful. Mathematically. Okay, maybe. So much hope. Okay. All right. Yes, ma'am.
Is that because when you're looking at the median, you're looking at kind of like, you're looking at the middle data point, right?
No, it's not even that. It's not even a data point, is it? It's just the middle of the numbers I'm looking at.
Okay.
So it doesn't have anything to do with all 3 of these at once.
Versus like the actual mode? No. Oh, man, I'm getting confused.
The actual mean.
Yeah,
Yes.
The actual mean takes into account everything.
Yes, it does. And that's
Okay.
part of the reason why this works. Is if I make that number 8,
Yeah.
then the population median suddenly is 8. The population median is anything I put in the middle that's actually between 4 and 9. So it's rather arbitrary. Now, if I do make that 8, it changes some of these values, right? But they still won't hit it. Because each one of these only has 2 things to look at. And they don't care what the third thing is. But if you do the average, everything comes into play into the average. So if they're averages of averages, that should still be the real average. They work together. Even if you took now this is what's interesting to me. If you put this in order, let's see. Let's try to put this in order real quick.
4,
Let's see. 4, 4.5, 4.5,
5,
5,
6.5,
6.5, 6.5,
7,
7, 7, 9. Is that everybody? 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. What's the median here? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. No, look. Yeah? Isn't that the median? 1, 2, 4, 1, 2, 3, 4. Yes. Even the... I don't know if anybody might have this thought, but even if you do... Now think about it. Taking the average mean is sort of gaming the system, you might think. Because you're like, well, you're taking the averages and then you're averaging those. They work together. Well, even if I take the median, right? These are all medians. You with me? These are all medians. And if I take the median, I still don't get the actual median. So you can't argue that it's because I'm doing the mean, so they're working together. It's not even that. It's not even that. You would never do that, by the way, but it's an interesting little side note. It's not just because of that. It's actually something more than just that. So when they say what targets the parameter, there's two things we know now for sure. The mean and the variance. Good. So you still have to check out the median. We just did. The standard deviation. Is there another one they do? Ooh, they do the proportion. I like it. Yes. And I don't know. You have to see which one actually targets and which one doesn't. So tell me again, what does it mean in order for a statistic to target its parameter? What does that mean?
It says something about the population as a whole.
So the mean, the sample means target the population mean because the average of the sample means is the population mean. The standard, the medians, the sample medians do not target the population median because the average of the sample medians is not the population median. So that's what target means. Because what do we want to have happen? When we pick a bunch of samples, if I pick enough or pick a large enough, they should become close to the real value. And the reason we're so used to just saying that is because we normally talk about means for doing that. Now we just, for this chat section, we've blown it up. We say, what any number, any parameter I can come up with, let's investigate if that's true. So it's true for the mean and it's true for the variance so far. And we know it's not true for the median. So you guys got to investigate standard deviation. Already gave away, it doesn't work. And then the proportion, that one I'm going to leave up in the air. I actually have one mystery. Good. You know, like, yes, it's going to motivate me. I'm really curious now. Come on, let somebody be like that, please. Somebody be like, I want to see if this is going to work. Like, no, I want to get the homework done so I get credit for it. That's all right. I won't take it personal. All right, so 6.4 is definitely weird. Well, the weirdness, the true weirdness of 6.4. 6.4 is so weird. And then 6.5, damn. I was about to say, you have to let it be easy. Because the only thing, if you understand 6.2 and 6.3, 6.5 should be a breeze. Because exactly like 6.3, really, except you don't use the standard deviation they give you. When they take a sample and they ask about the means, you change the standard deviation using a little tiny formula, right? Yes?
What do you mean by proportion for that?
Oh, proportion is just the percentage.
Okay.
So, let me see. And I think they use a different, I was going to say, for the population, find the proportion of odd numbers. So what's the proportion of odd numbers here? Meaning, what's the percentage of odd numbers in this list?
66%.
66.66%, right? You with me? Yeah. Now you're going to do the same. What's the proportion of odd numbers here? 0. Proportion of odd numbers here?
0.5.
Yeah, 0.5. And keep going. You make all the little sample proportions, average them out, take the mean of them, and compare it to what we got here. Same idea there, right? Okay, maybe. Of course, proportion has the extra added thing of you have to define something you're looking for, right? Proportion requires you to say, I want the one that's got no curve. Sorry, the 4's got no curve. You gotta talk about some characteristic to count and to not count, right? So they chose odd numbers. And you can pick anything. Which ones are divisible by 2? The proportion that are divisible by 2. You kind of with me? And whatever you pick, it actually will come out the same as the one that they chose. I won't tell you. I want to leave something. Right? You're all like, the mystery is just killing me. No. Is anybody like that? I don't know. All right. It's just me. I know the answer, so it's not even me. Damn. Okay. So 6-5, you expect it to be this horrendous thing. And if you do that, you're going to kind of shoot yourself in the foot because you're going to be making everything harder than it really is. Like I said, the only difference with 6-5 is you don't make a z-square x minus the mean divided by standard deviation. You divide it by the new standard deviation in the right place. So a lot of the homework problems they give are exactly the kind I like to give on a test. If you look at the practice test, if I had any left, let me see. Wait, I think I have. There we go. Here we go. Number 5 is a beautiful example of this on the practice test. 5A, part 1 and 2, I say we pick 1 student. And then 5D, I say we select 33 students. And then what am I actually asking? 5A, I ask the probability x greater than 315. So the probability of 1 being greater than 315. What's the difference with 5D? Number 1. Select 33 students, and what's the question asked?
Probability.
So what's the probability that we find 33 students?
No. Careful. Yeah, true. But 33 students what? Sample mean. So what are the 2 things that tell you when to do this little dude here?
To change the standard deviation.
Yeah. When do I do this? It's actually in the problem itself. When I take a sample, and they ask me about the sample means, that's when I do this, right? Both things have to happen. Yes, ma'am?
We do our formula sheet.
Yes, let's do it. Yay! All right. So, as long as you have a, I thought it was my phone. As long as you have your old formula sheets, you didn't lose any points. You can bring those back. You can rewrite them and bring those. You can bring as many freaking formula sheets as you want. You just got to turn them all in, and they all better have only formulas on them, right? So let's see, this test starts in chapter 5, so we got these little dudes here. Now please. So this is formula sheet. This is definitely not formula sheet. Do not let me see. I mean, come on. That's a note. That's an example of how to set something up. You got to know that. And I give you the damn things. You just got to label them correctly. I still see, but what is it, just for the sake of remembering what I put here, what do I put here?
X squared px.
Yes. Why would it make no sense to have a symbol like this up here? It's the sum. I got to get them first before I can add them up. That's what that means. The formula says it needs a sum of these. Okay, I need those before I can add them up. Right? So I make a list of these so that I can add them up and put the number I get here. And the mean you'll already have from the previous column, right? Okay. Good. So don't, not, bad, lose points. Then we got this dude here. What is this for? Yeah, you can even put a little line there. You've entered a new idea. I don't say you can't have lines. right? And then don't say, well, words are just a series of lines. I've had some real smart asses in my life. And then, so what's the mean for a binomial situation? NP. Gotta love it. And what's the standard deviation?
Square root
Root.
of NPQ.
NPQ. Kick ass. What's got to be true about P and Q? Several things.
They have to equal.
They have to add to be 1, and they each have to be
More than 0?
Greater than 0.
more than 0
And less than 1.
and less than 1. I get way too often people put 35 and 60 there. No, they have to be probabilities. They can't be bigger than 1. And that's where you start getting really weird-ass answers. And you start getting z-scores like negative 14 million or something. I mean, and you're like, Jeff, this is mean. I'm like, I didn't do that. You did that. That's not my intention. So be really careful. Those got to be actual probabilities. So again, so on this board, not on your formula sheet. If I said we took, it doesn't matter, Jeff. 73% of people can't read my writing. We take 87 people. What's the probability that, what you got, Jeff? I don't know, 70 can't read my writing. Right. I get way too many people tell me, they say, okay, N is 87, good. Then they say P is 70 over 87, and they calculate that. Okay, well, what's wrong with that? What is P?
73.
Yeah, it's the probability of a person. Because the first person would be 73%, and the second person would be 73%, and the third, if I wanted everybody to not be able to read my writing, they would each be 73%. I don't accumulate. If I took 800 million people, it would still be 73% as P. Because it's individuals. It doesn't matter how many people I take total. So be careful about that. I see that all the time. And then what would Q be? Yeah, 0.27. I like it. I like it a lot. All right. Let's see. What else do we need here? The semi-new stuff is just the end of section 5. Then we got into section 6. You can put this down again, of course. If it won't confuse you, you can put this down. Same formula. What's the only difference between those two?
Sample.
Yeah, that's for populations per sample, but the idea remains the same. And the only really new thing is the new standard deviation here, right? So you can't have any notes for yourself. Use this when. I don't want to see some weird symbols. I don't want to see a lot of erased writing. Right? I love it. One person actually put a whole bunch of notes in the back of the formula sheet, like I wouldn't turn it over. I'm like, all right. What are you trying to say about your opinion of my intelligence? Yes.
About mu equals C times.
Ooh, I like it.
division.
So x equals
Oh yeah.
mu plus
C times standard
Z.
deviation.
sigma. I like it. If you guys might remember, if you can say that in English, that's the answer to a question you know is going to be on the test. What does the z-score tell you? The z-score tells you the number, standard deviations away from the mean. 2.
A point.
A data point. So you can read this in English and it answers that question, right? Okay. I'm not going to put a bet on how many people will miss that question still. I almost want to. I'm just not a betting man.
Wait, it's going to be on the test? What did you say it was again?
So what did I tell you a long time ago? It was going to be on every single test. What does the z-score tell you? Or an alternate version would be, what would a z-score of 3.9 tell you, or something like that. Now be really careful. I'm going to give something away. If I said, what would a z-score of 3.9 tell you? What would the answer be? Yes, that's it. That's the answer. If you say anything about area, you are desperately wrong. For 2 reasons. One is, I didn't tell you if it's normal or not. What's the only time you can look at the normal probability, the z-score chart, and tell me probabilities? Is if it's normal. If I just say, what's the z-score 3.9, you don't know where the hell it came from. Secondly, that's not the z-score telling you that. It's the z-score chart telling you that. What does a z-score by itself always tell you? The number of standard deviations away from the mean to the data point is what it always tells you. Someday I will get everyone get that right. That would be, how come he cried?
Okay.
Okay.
How many z-scores?
Someday I'll also have everybody get that one wrong. And I'll come and crying then too. I'll take this as a challenge. Anybody else have another suggestion for a formula? My memory is certainly not infallible. I believe this captures everything so far. We haven't gotten to chapter 7 yet, so we're going to get many, many formulas from that when we get there.
What's that formula down there? The mean? Yeah, that one.
All right, so I'm glad you asked me that. So very often people will write that and they'll think too much of this little subscript. This is a single symbol, right? This is not sigma over x. This is not sigma divided by the mean. This is the standard deviation of the sample means. That's what that represents, right? Because again, if I go to Florida and I graph individual people and they do weird shit, that's sigma tells me how far apart they are. But if I go to Florida and I take groups of 31, it'd probably be more. Here's my OCD stuff. If I take samples of size 31, that'll be sigma x bar, because it's not standard deviation of individuals, it's standard deviation of sample means. In fact, what does the calculator, look at the calculator, what's it give you? It doesn't just give you sigma, what's it say? Sigma x. It gives you this, standard deviation for individuals. And this is the standard deviation for groups, their means. Kind of like that it does that. Okay, good, you good? So that's not something divided by something, that's something divided by something, right? So what was your question? I'm sorry, is that it?
You answered it.
I love it, okay.
Didn't remember seeing that one at all.
I was making an assumption and that was the question, okay, good. Because, the other thing is not really a formula. What's the mean of the means?
The same.
Same, I love it. It's equal to the mean. Right? That's the thing I was saying earlier. Just because I take 2 of you at a time, it's not going to suddenly change the average age in here, right? That would be strange. I take 3 of you at a time, everybody suddenly gets older or something. Stop, Jeff! No! Stop! That would be neat. And I'm just sucking all your age, I'm getting younger. Then to get 4 of you, no, Jeff, stop! I'm too weak.
I can just see you
I'm younger. There's just dust in the chairs. No, this is not my plan at all. Anything else? Yeah. That's the magic of math. Anything else? Any other formulas you think should go up there? If not, this is it. All right, that's all I want to see right there. That's all you can have in your formula sheet. And you can have any previous formula sheets, and only the things you had before could be on there, if you want to bring those. Okay. All right. Let me go ahead and give you guys the answer key for this thingamajig here.
Well, now I'm scared. I don't remember that.
Antonio.
Sample standard deviation.
So if you look at 6, I don't know if you'd try that one yet, but the z-score you get from number 6, C, should be, it comes out to be 4.44. That's way off the chart, right? So you can either give me the book's answer, which is the z-score chance answer, which would be 0.999, or you can say it's about 100%. Because that's, the further you get past 3.5, the more and more stuff you accumulate, it's getting closer and closer to basically 100%. Sort of like me saying, let's probably go out and randomly pick somebody and they're less than 8 foot tall. That's basically 100% chance that's going to happen, right? Biologically, maybe there's chances make it be taller than 8 feet. But for us humans, it's basically 100% chance I'm going to find somebody lower, shorter than that. I still really haven't gotten a lot of homework. I'm a little concerned because there's not that many of you who are on my math lab doing it that way. So hopefully everybody's just going to turn in on the day of the test. I guess you are. It kind of sucks for me and you because, I'll grade that someday. Yeah.
For 4B, how did you get that one? I was confused.
Where are we at? Oh, 4B. Okay, that's a good question. So does everybody understand that idea? The z-scores bounding the middle something or other. So what's got to be true then about the z-scores themselves? They have to be symmetric, right? Boogie woogie. So if I want to capture, bound, the middle, what was it? 91%. So I want these two z-scores, since they're symmetric, if that one is 3, that one's going to be -3. And I know because it said the middle, so forth. The middle such percentage. Right? So how much is in here?
91.
Yeah, good. So if you look up 0.91 on the chart, why would that have nothing to do with the situation? Because the area, where's the area here? Between two z-scores. And the area that the chart understands is
The z-score.
below a z-score. So the easiest thing to do then is say, I want that z-score, for example. So what's this area below there? And I can get that z-score. So if there's 91% in here, how much is outside? 9%. So how much is on that side? 4.5%, 0.045. The larger issue here is if you want to find a z-score on the chart, you have to look up an area below that z-score you want, period. If the area you're working with is not such, find the one that is. And I didn't change anything about if it bounds the middle 91%, there has to be 4.5% below it. So that's another way to say the same question. Yes, sir?
So what's wrong with the camera?
It's probably battery. Yeah. Pover little dude. Okay. Oh, maybe you got it. Yeah, it did. Does that make sense there, that idea? So what do you get? What's the closest area you can get to 0.045? You guys comfortable with doing that?
955.
Let's see, does that have some charge? Let me see. Did I bring some? I guess not. Shoot. I did.
1.70.
For sure I did. Oh, too bad for me. Where are we at? So the closest I can get to 0.045.
-1.70.
I want you guys to really see this. Someday. Let's see. Oh, there we go. Alright, the closest I can get to 0.045 is 0.0. These are so tiny, it's crazy. 0.04. There's 0.0446. And over here is 0.0455. Which one's closer to 0.045? Yeah, 0.446. Now, if you wanted to, you could split the difference. So you could just say this is the closest one. It'd be negative 1.70. That's where I got that z-score from. The z-score, negative 1.70, has almost 4.5% below it. That's exactly the z-score I want. Yes, sir?
That's another thing. We can bring the little blue Z.
Please do. I'm going to bring some more because I think a few of you guys didn't get one. I thought I brought them. Obviously, that's wrong. So I'll bring some more on the day of the test. But bring your little z-score charts, right? If you wrote anything on them, notes or anything, you don't use them. Right? You're going to turn them in with the test, and then you'll get them back, and you'll keep using them. Don't write on them. You with me? Okay. Maybe. Everybody understand? You guys are still looking at me like... All right. So, if I ask you... Here, you guys, find the z-scores that bound the middle 60%. Good. Both sides are 0.2 or 20%. So the closer I get to 0.2, does everybody see that? So if there's 60% in here, how much is outside? 40. How much is on that side? 20. There you go. That's how you do it. It's symmetric. So you got to cut in half what's left over. This middle caught 60, so there's 40% left outside, right? 20% on that side. Why the hell am I curious about that side? Because it's below one of the z-scores I want. And if that's -2, that's got to be +2. Right? So you can do the same. How much is below this z-score?
80.
80. So you can look up 0.8. I don't care. Find one of your z-scores.
What I was taught was, my tutor was, you take the 1 minus the 0.60, and then you divide it by 2.
All right, cool. I love it. In general, I'm not a big fan of memorizing procedures instead of just realizing it's not a very, it doesn't require that kind of thinking. But if it works for you, awesome. But all you got to think is if there's 60% in there, there must be 40% outside, must be 20% on one side. Mathematically, that's what that accomplishes.
Okay.
So if that works for you every time, kick ass. But you shouldn't need that.
Okay.
But it's okay if you okay, so now we got this 0.20 there. The closer I get to 0.20, and I'm going to look out here, 0.20, and then get the answer. That's an area, so it's going to be in the middle. So the closer I can get,
0.91977.
0.2005. That's pretty damn close. And that is -0.84. Something. 4? 4. So what's up here?
0.8.
Positive 0.84. Yes, sir.
Didn't we not want to go over 20? No, or no?
No, the closest. The closest. Yeah. Doesn't matter. The closest. Cool. Because trust me, when I took stats, we actually had to interpolate, create a linear equation between the two possible answers. And so it would be closer to this, but drag down a little bit because of that. You can do that if you want to. It's not really necessary. Because to tell you honestly, I mean, there's a whole reason I use this chart. There are some of my colleagues that don't use this chart at all. You can just do all this in the calculator. I'll go ahead and show you how you can do it in the calculator. I will. But you lose something when you don't look at this chart. You don't even realize that you're picking up how these things are kind of spread out. And you have to think differently when you need to look at the chart. It's a little more tactile. If you're just pushing buttons and getting numbers out, very often you won't do the right thing with them because you're not as connected to them. So in the calculator, you guys might remember when we did binomial CDF and PDF, there was a normal CDF and PDF. So if you go to second vars, the first one is a little freaky. We never pretty much use it because, let me see if anybody gets this. In a normal distribution, what's the probability of exactly some value? So what's the probability of exactly, whatever value this is, what's the probability of exactly that? Doesn't even matter what it is or where it is. What's the area of a line?
1.
Nope. How wide is a line?
Very thin.
Very thin, remarkably thin. So thin that it doesn't exist, basically, right? So the area of a line is 0. So the probability of any specific thing happening in a normal curve is 0. So that's why we're always talking about accumulations, right? From here to here, in this area, in that area. Speaking of a specific value, theoretically, any specific value on this curve will have a probability of 0. It's not truly 0, because then you could argue, like I did when I first took probability, that you add 0 up forever, you get 0. So it's actually, what's the biggest number? It's actually a process. What's the biggest number? Biggest, infinity. So it's not really a number, right? So the reverse of that is called iota.
Oh,
Right? I don't know if anybody's ever heard the word iota.
no.
Right? You got an iota chance. Blah, blah, blah. It basically means you have 0 chance to do something. Right? Anyway, that went way further than I intended. But let's go back up. So let's double check this. Let's see what's the area between negative 0.84 and positive 0.84. So I want to use number 2, your normal CDF. And all you do is you put in there negative 0.84, comma, positive 0.84. And you get 60%. Right, so a little bit off because of the half-half, like you were saying. But again, normally humans can live with that. Depends on the situation. Obviously, if I had to be very precise, I would only use technology. But we don't have to be very precise in a learning environment. That's why I make you use the chart, because that's better for learning how the hell these things work. And by the way, if you didn't have z-scores, if you had, let's do one off the practice test real quick. That very first problem, number 5, probably x greater than 315. So somebody help me out. What's the? And here's where things get a little bit weird. So if I want to be greater than 315, I want to go from 315. And I really want to go from 315 up to infinity. But let's just put 9999999. And that's perfect. That's infinity enough. Right? I don't know if everybody gets that. If you don't get this at all, it's cool. You don't need the calculator at all to do this work. So that's 315 up to really big. But those are not z-scores, right? If I don't put anything else in, then the normal CDF assumes they're z-scores. And that would be really freaky as z-scores. It's going to tell me 0, dude. So I want to put the mean and the standard deviation after that. Comma mean, comma standard deviation. So what's the mean for this problem number 5? Do I have it here?
281.
Yeah, 281.2, comma. Standard deviation was 34.48. And there's what was the answer for number 5A with number 1? 0.1635. Nothing amazing there. It's just doing exactly what we did, just a little more precisely. Everything it does is more precise because our z-scores can only go out how far?
3.
Z-scores can only go out how far? The chart. How many decimals can I look up? 2. I can only take this, so I have to round there, and then the probabilities in the chart are rounded to 4 places. So there's double rounding. So that is just a more precise answer to what we get off the chart. But for learning purposes, who gives a shit about precision yet? Right? And when you get out of the real world, you're actually using statistics. If you're in a business, and if you're a financial analyst, and you've got to use statistics, believe it or not, you do. You're going to have statistics software packages that do a lot of the work for you, right? In which case, I'd always have somebody go, "Oh, we got to learn this shit," because you probably want to be able to interpret it, right? Garbage in, garbage out. Just sit anybody in front of a freaking computer. You think they deserve that job? No, you got to learn this shit. All right, sorry. Yes.
How would you do that without the calculator? Would you just look up the areas?
Yeah, the way we did it. That we never did that before, but we've done problems like this over and over and over again, right? So you would just make a z-score out of 315. Look it up in the chart. Do 1 minus that because I want above, and then I'm done. That's how I got the 0.1635. So that problem, 5A number 1. Let's do that problem real quick. So what would I put in the middle? I know it's normal, right? I tell you at the beginning it's normally distributed. Please tell me it did. Good. What goes right in the middle? 281.2. I want to know the probability that it's greater than 315. So I take that 315 and I make a z-score out of it. 4.8. And then you get 0.98. Please really, if you get z equal to 0.9, I can't remember what I got, but if you get 9762, don't say it's 0.97. Round it. Don't just cut it. Round it. You will lose a point there. Let me see, where am I? Oh, so we got our z-score, so how do I look that up? So now my z-score there is 0.98, which makes sense. It's a little less than 1 step up from the mean. So if I look that up, I'm going to get the area where? Underneath? .8365. Good. And then 1 minus that is the actual answer, which is 1635, which is what that's trying to say right there, right? So this is a nice way to check your work. Here, I better see your work. I better not see the number coming out of nowhere. You with me? But this is a really good way to check your work. You just realize that it could be, this came basically right on top of the answer that we got. But because of the rounding we do, just to use a chart and the probabilities they give me, it could be a little bit more off here, but it can't be like crazy off. Maybe only this number would be different. It shouldn't be much more off than that. If you don't want to use your calculator to do that, you definitely do not have to. Yes?
For 6-1B, did you, after you get the equation, do you subtract or do you add them together?
So you got to put that on there. There it is. So the probability x less than 22. So when do I want to do that 1 minus process? When do I want to do that?
That was 1.
When the opposite situation
It's more work.
has less work,
Oh,
right?
yeah.
So the opposite situation from what they're asking me, if it has less work, I'm going to do 1 minus that situation. I got less work to do then. So if it says x less than 22, well, what could that be? 21, 20, 19, I don't like it. And part A, I think I asked for 22 exactly, right? So what's the opposite of less than 22? Greater than or equal to 22. So that would be 1 minus probability of 22 plus probability of 23 plus probability of
24.
Thankfully, there's only 24 total possible, right? So they only took 24 people. So when do you do the 1 minus thing? Whenever the hell it makes sense. You could do it every damn time. But the reason I'm going to do it when there's less work. This involves 21, 20, 19, 18, 17, down to 0. This involves, I already did that. So 2 more. Yeah, I'm going to do that way. Shit, yeah. This is not binomial CDF. And then, no, that's not showing me your work. Telling me what you typed in the calculator is not showing me your work. I always get somebody argue that. Well, I told you what I did. No, it's not. So this one you should get from part A. And then if you could set up part A, you could set up this and you can set that up too. Is that cool? So you could just add those 3 and then take away from 1, whatever you get. You can check your work with binomial CDF. Not a damn thing wrong with that. If you know how to use it. If you don't, you probably should stay away from it. Is that cool? Is that right?
No.
No. So what's up? What part of that?
So when I made the equations, I set them up correctly.
Okay.
You know how you add them together? So I did like I think 24C, 23, probability 88, and then I set up the equation correct.
Yeah.
But do I subtract it with the other one, or do I add them together to get the probability?
Oh, so what I did was I distributed the negative and just did it all in one line. What you could do if you want to instead is you could do that, you could do that, you could do that, add those numbers together, and then subtract what you get from one. Either way, it's going to be the same thing. What I did is I just distributed the negative, so I made it 1 minus this, minus that, right? And just filled in what that was from part A, put the formula for this there, put the formula for this there. So I could just do it in one line. You could do it that way. If you don't want to do it that way, you could do it the other way. You could just add these together and then take it away from one. Did one of those ways make sense?
Yeah.
Okay. Yeah.
Number 2C.
Oh. So this is sort of like what we were just talking about with the when do I do this turnaround thing? And even then, it's not that big of a situation. There's not that many things going on. So if I want x greater than 2, the first thing you got to realize is where are the probabilities in this problem? So even before I do any work, unfreeze. So I probably should have done this, but I could put this question there, because you don't have to do any work to answer this question at all. I mean, you have to do a little bit of work, but none of this work here. Because what's the probability that it's 6? 0.154, right? So it's greater than 2. Add up all the ones that are greater than 2, or do 1 minus
2.
the probability of 2. Because that's the only thing that it leaves out. That's the opposite of greater than 2. In this case is equals 2. That's the only thing it leaves out. Either way you do it, it's going to work. And it kind of is almost silly. What do these numbers have to add up to be? In fact, you'd show it in part A.
1.
They have to add to be 1. So of course 1 minus the first guy is everybody else. Because they all add to be 1. So mathematically it's like, yes, of course. Okay. But I always get people answer me with numbers from here. This number doesn't mean a damn thing until I add it to everybody else, and then I get the mean. That's the only thing these numbers are good for, really.
Is the practice test online?
No. Sorry. Did you need a copy of it? Yes? Okay. That's what I gotta say. Things still exist in the real world.
Yay.
As I say that, I'm like, do I have any left? Yeah, I have the one that's right there.
I could just get it from you after if you still need it.
No, I'm good. I don't need that. I got it on my computer.
Are you here tomorrow?
Yeah. What is tomorrow? Tuesday. Yeah, tomorrow's my long day. So I'm 11 to 12 in my office, and then I'm back in my office. I'm not back in my office because I have a meeting tomorrow afternoon, and then I have a 4 o'clock class. Yeah.
So just 11 or 12?
11 to 12 tomorrow.
Okay.
Yeah. And then Wednesday, I got all that time right before class that I'm in my office. You guys doing all right? You all look a little beat up. I feel like
yeah.
I'm responsible for that. Good, I'm doing my job.
You ruined everything. Oh, man.
I love the look on your faces. You all look at me like. So if you're ready, you can go. If you're ready, you're ready. What can I do for you?
I'm not ready, but I don't even know what to ask you. I think I just need help
Oh,
with like, the
all right. Just let me know.
calculator.
Yeah. Okay.
Everything else I think I'll be able to figure out.
Yeah. So, 31 years old. Okay. So it's not just nominal. It's a number. It's 31. So it's not just nominal. Nominal would be it's not numbers. Yeah. So it's not just a name. It's a number. 31. And so it's got to be interval or ratio. So I can certainly, if I was 42 years old, minus 31 is 11. I would be 11 years older than somebody who's 31. So differences make sense. But do ratios make sense? Yeah, if I'm 42, somebody's 21, and twice as old as they are, ratios make sense.
Because she like doesn't know.
So same thing in here.
I'm like, man, I'm like,
Oh, so not just 348 voters, it's got to be 348 likely voters. So the population would be all likely.
okay, thank you.
Sure.
Like it's hard for people who speak English.
Yes.
Could you show me how to use calculator for this one?
Daisy, is yours?
Where are we at? Oh, all right. So do 20. Math.
Alright, good luck.
And then probability. Right at the end, see that PRB. And number 3, see that's the choose. 20 choose 6 times 0.25. To the, 6. And then push over. Push over. There you go. See, that takes you out of the power now. Yeah. So that's the part that some people skip.